Cases when a limit is undefined. Take a look at this graph of y equals e to the power x. As x approaches infinity, the value of y is also approaching infinity. Now you can say the limit as x approaches infinity of e to the x is not finite, meaning it's not defined. Take a look at the graph of y equals tan x. Let's focus when x equals pi by 2. The limit as x approaches a value a bit lesser than pi by 2, you can see that it's approaching a positive infinity. And the limit as x approaches a value a bit greater than pi by 2 is approaching negative infinity. Now, the left-hand limit, which is the limit as x approaches a value lesser than pi by 2 of tan x, is not equal to the right-hand limit, which is the limit as x approaches a value a bit greater than pi by 2 of tan x. The limit here does not exist. Let's take another example. Consider the function we took in our last video. The graph of the function looks like this. Note that the function is not defined when x equals 2, because then the denominator becomes 0. You can't divide a finite number by 0. But we have noted that the left-hand limit and the right-hand limit are pretty close. They're pretty much close to 4. So hence, the limit of this function as x approaches 2 does exist, except the function itself is not defined. Let's look at a few fundamental theorems on limits. Consider two functions, f of x and g of x. Let's assume the limit as x approaches a of f of x to be L, and the limit as x approaches a of g of x to be m. The limit as x approaches a of f of x plus or minus g of x can be written as L plus or minus m. Similarly, this can be written as L times m. And here, you can express this limit as L divided by m, given that m is not equal to 0. This limit can be written as the limit as x approaches a times k times f of x, and here k is a constant. You can take the constant out, so that's k times the limit as x approaches a f of x, and this we already know is L, so it's k times L. And the limit as x approaches a of f of g of x is the limit as x approaches a of f of the limit as x approaches a of g of x, which is m. And considering that f is defined when x equals m, we can just write it as f of m.